we're going to go to 0, 5, and we're going to find our sine, cosine, tangent, and secant, cosecant. And I know that 0, 5 wouldn't be left or right, it'd just be up at 5, and would just be this 90-degree angle that you're making as your theta. But then it becomes hard to make because you can't really make a right triangle out of this. So let's kind of generalize what we've been doing up to this point. Up to this point, we have been, let's see, drawing our triangle with our angle theta. And let's say if it's in the first quadrant, we have our right triangle here. We have our point that we started out with, which has an x and a y. And then what happens is then we fill out the x goes along this side, which is our adjacent side. And then we have normally our y value, which goes along the height side, which is our opposite side. And then we have our hypotenuse side, which I'm going to start calling r. And we'll use this a little bit too, because later on it will be the radius of a circle. So it'll look something like that. So it'll be the radius. Assuming I could draw a very nice circle like this, it would be the radius. Again, assuming I could draw a little bit better, but that's kind of the idea. So let's fill in our 0, 5 on this picture. Would look something like this. And again, it'd be 0, 5. And then that would mean that our adjacent side, our x side, even though I'm drawing it in, would be a 0. It's like having a 0 on that side. And so that would be where our x would go. And then our y would go on the other side, be our height on our right triangle, which would be 5. And let me make sure I know it's a right triangle with our angle where it normally is, which is in that corner. And then my radius would be my hypotenuse, my r. But how do I find that radius? Well, again, notice it's a right triangle. We'd have to use our Pythagorean theorem, which would be a squared plus b squared equals, and this side, the other side is actually r squared. The hypotenuse is actually r squared. And we just said our one side is our x side, which is our 0. So you could actually use x instead of a. And that's going to be 0 squared. Plus, our other side is actually our 5, which is our y side. So that'll become 5 squared. And our other side is our radius squared that I'm looking for. So again, we got a new version of the Pythagorean theorem that looks like x squared plus y squared equals r squared. And if you actually kind of think back about this formula, it's still the Pythagorean theorem, but it looks a lot like the formula for what? The formula for a circle. Remember, circles, this is not a coincidence, have an x squared term, a y squared term, and then on the other side, you add them and you get the radius squared. That is not a coincidence. If you remember this from college algebra, that is exactly going to be our link between circles and right triangles here. Very interesting. Now, continuing right along, we'll have to do our exponents first, which gives us 0 squared is 0. 5 squared will get us 25. And then we can go ahead and do our addition, which is going to give us 0 plus 25 is 25. Be careful, that's our r squared, not our r. So if I wanted to get r, I'd have to take the square root of both sides, which would give us that r equals the square root of 25 is 5. That means our hypotenuse is also 5. So continuing along now, I would be able to find my sine, cosine, tangent, everything else. So we have our sine, cosine, tangent, and all of the same angle theta. And we're going to use our little mock right triangle. I know it's weird because one of the sides of the right triangle looks like it's 0, but that's okay. It's kind of like just a fill-in at this point. We are going to use it though. So remember, sine is opposite over hypotenuse, which in this case, if we were looking at labeling these as x, y, and r, opposite would be our y over our hypotenuse, and this one would be r. And so that would be, and I do want to get used to this because this will make our lives a little bit easier if I start thinking about this as y over r. Our r was, our radius was 5, and our y here, or our opposite side, is 5 as well. So we get 5 divided by 5, which is just a 1. So my value of sine is just 1. Okay, now I can do cosine, which is normally instead of cosine is ca, would be adjacent over hypotenuse, which would be adjacent is the x side over the hypotenuse, which is again r in our new picture. So we have our radius is 5, our hypotenuse is 5, and our adjacent side x is, according to that picture, 0. Now notice something here. We get 0 divided by 5, which is just 0. So cosine is 0. Last one, tangent is TOA. Well, in this picture, TOA means opposite, which would be your y side, over your adjacent, which is your x side. So it'd be y over x, which would be 5 over 0. Okay, there is a small problem here, and that is what? Is we have 5 divided by 0, and we know that anything divided by 0 is what? Undefined, because we can't divide by 0. So tangent of theta is actually going to be tangent is undefined. And the reason being is this part above is because mathematically speaking, we can't divide by 0. Ever. Okay, so that's 3 out of 6 trig functions. Continuing along, let's work on cotangent next. Well, remember that cotangent is just going to be the reciprocal of tangent. So instead of y over x, it will become x over y, which means that we'll actually get 0 on top and 5 on the bottom. Be careful, that is not the same answer that we got for tangent. Remember, the reason we got undefined for tangent is because you can't divide by 0. However, 0 divided by anything is indeed 0. So you can actually find cotangent. It will be 0. Next one, cosecant. Remember, the two cos can't go together, so cosecant actually matches up with regular sine, and it's going to be its reciprocal. So if sine was y over r, cosecant's going to be r over y, which means that we'll end up with r on the top, which is still 5, and y on the bottom, which is still 5. So 5 divided by 5 will still get us 1, which makes sense. The reciprocal of 1 is 1, and that's what we had for sine. Last and final trig function is secant of theta, which should be the reciprocal of cosine. Well, cosine was x over r, so this will be r over x, and remember x was 0 and r was 5. Well, we just did something just like this. We get 5 divided by 0, which we can't do that. Remember, we can't divide by 0. So this is another one that says cannot divide by 0. Which means what? That secant is going to be undefined. So we'll say secant of theta. So secant of theta is also going to be undefined like tangent was, because we can't have a 0 in the denominator of a fraction. We can't divide by 0. In this next group, we're going to use a quadrant.